Assalamu alaikum everyone. I am Asan Habib Habi. Today I'm gonna present my topic load balancing algorithm in cloud computing. In this presentation, I will explain what load balancing is, why it is important, different type of load balancing algorithm, and where they are used in real life. So let's get started. What is load balancing? First, let us understand what load balancing means. Load balancing is the process of disturbing incoming requests or workloads across multiple servers. Instead of sending every request to a single server, a load balancer works like traffic controller. It decides which server should handle each request. This helps in three major ways. First, it improves scalability, meaning the system can handle more users. Second, it increases availability because if one server fails, another server can continue the work. Finally, it improves performance by reducing response time for users. Why we why load balancing matters. Now, let's see why load balancing is important in cloud computing. Cloud traffic is not always the same. Sometimes many users access a website at the time. Load balancing distributes this heavy traffic among different servers. It also improves resource utilization, so no server become overloaded while others remain idle. Another important benefit is fault tolerance. If one server stops working, the load balancer automatically redirect traffic to healthy servers. Finally, load balancing supports auto-scaling, allowing new servers to join automatically when demand increases. Types of load balancing algorithm. Load balancing algorithms are mainly divided into two categories. The first type is static algorithm. This algorithm uses fixed rules and do not check the current situation of the servers. They are simple, fast, and suitable when workloads are predictable. The second type is dynamic algorithm. This algorithm monitors server health and workload in real time before making decisions. They are better for cloud environment because cloud traffic changes frequently. Static algorithm. Now let's discuss some static algorithm. The first one is round robin. In this method, requests are sent to each serve one after another in order. The second one is weighted round robin. Here each serves grades a weight ballot based on its capacity. A strong server receives more requests than a weaker server. The third party on is IP hash. In this algorithm, the client IP address determines which server handle the request. This helps keep the same user connected to same server during this session. Dynamic algorithms. Next are dynamic algorithm. The first is least connection. The load balancer sends the next request to the server with fewest active connection. The second is least response time. This algorithm chooses the server that responds the fastest. The third is resource-based or adaptive load balancing. It checks CPU uses, memory uses, and network status before selecting the best server. Because it uses real-time information, it provides better performance in cloud system. Advanced and AI-based algorithm. Modern cloud performers also use intelligent algorithm. One example is machine learning load balancing. It predicts future traffics and prepares resource in advance. Another example is genetic algorithm, which search for the best way to distribute tasks. At colony optimization, be copies the behavior of ants and find efficient route. Finally, fuzzy logic helps make decision when server information is uncertain or incomplete. This advanced method improves efficiency in large cloud environment. Static versus dynamic optimization. Now let's compare static and dynamic algorithm. Static algorithms are simple and have a low overhead. However, they cannot easily adapt when traffic changes. Dynamic algorithms are most flexible because they are use real-time server information. Although they require more monitoring, they provide better performance for modern cloud applications. So dynamic algorithms are generally preferred in today's cloud system. Real odd uses and challenges. Many popular cloud provides us load balancing. For example, Amazon Web Service uses elastic load balancing. Microsoft Azure provides Azure Load Balancer and Application Gateway. Google Cloud Platform also offers global load balancing servers. However, they all are still some challenges. These include managing users' session, monitoring continuously, coordination with auto scaling, and maintaining security while distributing traffic fairly. To conclude, load balancing is an essential part of cloud computing. It improves performance, increases reliability, and helps cloud systems handle large number of users efficiently. Different algorithms are suitable for different situations, but dynamic algorithms are widely used because they can adapt to changing workloads. Thank you very much for listening. I'm happy to answer any question.